Chris Berry, and I'm a senior ME student here at UB. I'm here tonight to talk to you about 3D solid laser modeling. It's a technique that you use for creating CAD models and for doing CAE simulation, things like that. It's a modern technique that you use to model physical objects and take it into the virtual world. What you need is you need an HD laser, you need a software to take it from the laser and take it to the computer, and you need a CAD software to do post-processing. I use SolidWorks in this case. What is laser modeling? Basically what you do is you create a cloud mesh system, which basically represents the geometric surface of the laser beam. The laser beam records distance from the laser to the surface, and it transports that information to a computer. You then recreate it in a reconstruction software package. This here is a picture of the laser scanner that I used. It's located in the 4th floor of Bell Hall in the IE laboratory. Basically, this is the mechanics of the scanner. This plate right here rotates, and this right here is the scanner itself, and it moves in a vertical direction. And basically, it just moves in small increments and then takes a full 360 scan of the object that you're working with. Data acquisition. Data from the lasers can transmit to the computer through a USB cord. In the software that you use to get the data, you can manipulate the parameters such as the height of the object that you're scanning, the resolution, the laser beam pitch. So it's more like an angle, so if you had something that had like funny angles on it, you can manipulate the laser to get a better scan. This here is the reconstruction of the object that I did. I used just a general coffee mug. This here is what shows up in the software. This is the point cloud system. Once you have that information, you then convert it into a format that CAD program can use, and that's what I use. I use an STL file, which is a stereolithography file. This allows you to post-process data in whatever CAD program you want. I use SolidWorks, but you can use just about any program you want. Post-processing, the purpose of doing that is so that you can eliminate, if you look here, you can see in the scan, there's like near the handle, there's like little particles. It's just errors that occur with the laser. I mean, as you get more expensive lasers, these errors are less prevalent. So post-processing, you can increase the accuracy of the scan with the solid modeling software, and you can reconstruct the object so that it can utilize a CAE platform, so you can put it in a model. First phase of post-processing is importing the scan into SolidWorks, which is actually a little bit of a process. Basically, in SolidWorks, if anybody's familiar with it, what you need to do is you need to first enable an add-in called Scan3D. Once you do that, you can open the file as a mesh, and that's just, you have to select that in the parameter below where the file is listed. You can then import it, and what you see here is a mesh, surface mesh of the part itself. It's a little bumpy, but that'll be taken care of later on. What you do is you then open up the Mesh Prep Wizard. You select the mesh you wish to process. In this situation, there's only one mesh, but as your parts get more complex, you can select different components of the object. I selected no orientation. This is just for the data purposes. There's tools that you can use to select the material that you want to delete. This is more like of an art. You have to play around with it for a little bit, but after a few times you can get the hang of it. You use that select tool so you can delete excess material. You can see on the left side where there's that little bit of pixelation, and on the right side you can see how I remove that. Next, what I did is I simplified the mesh size. And what I'm doing that for is so that I can reduce the resolution of the mesh, so it gives it more of a smooth surface. You can see here how it did change. Next, what you do is you change the global smoothness so that it averages all the contours of the object to give it a more like an average, so it's a more of a consistent surface, which is more that I scanned. Next what I did is I increased the boundary smoothness. You can see here there's little broken sections in the left side. It's jagged, and that was before I applied this technique. And on the right side you can see how it's more smooth. And the reason I did that is so that I can apply a molding technique next to fill in all the gaps. Here it is. I selected the base and little sections of the handle. You can see it in red. These are areas I'm prepping for the filling technique with the molding tool. And this is after I implemented that. Next what I'm doing is I create the surface model, which breaks it up into little mesh segments. So now instead of it just being a giant mesh, it's now into little sections. So now you can manipulate little specific sections of the object. And it prompts you to delete surface areas. Basically, if there's like little overlaps in the surface where it's not smooth, this gives you the opportunity to delete those, and you can just recreate them easily with the molding tool. And this is what it looks like before the post-processing begins. Basically, you can see here the little blue sections represents the mesh, the little mesh sections of the object. Here you have to enable the mold toolbar. This is something you're probably not familiar with, but you can see here, just follow the logic tree yes and how to get there. So once you've enabled that, you can create surfaces from the whole edges. So what you do is you select the edging for the object, and you can see here these are just basically pre-fill selection. What happens is you select the region you want to fill over, and it creates kind of a mesh grid, and then you just basically select it and just fill in all the holes. You can see here how I fill them all in. So basically you do that, and then when you're done with everything you desire to fill in, you basically you're left with this, which is more of a really fine grained surface. And then once you'll basically open up another tool for post-processing. It's called PhotoWorks, and you can do like a high res render of the object. And this is what it looks like at the end. The background is just superficial, but that's what the actual object looks like after the post-processing. It's pretty similar to how it looks in the real world.
So does it have any thickness to the wall, or is it?
There is a little thickness. What you can do is you can do a post-processing technique of increasing the thickness, just like you would on any solid model that you create off of just a 2D object. It's the same property. What are the benefits? The benefits are saving time modeling complex components. This right here, this coffee cup, took me about 8 minutes to get that scanned, but I could have turned the resolution down. But the benefit of doing that scan is you can get an accurate representation of the surface, which is impossible to achieve with current CAD softwares, such as wood grains, bumpy surfaces, curves, grooves, things like that. It would take forever to model them. So this is hugely advantageous. It also allows for better analysis in CAE platforms, like fluid flow over surface, pipes, and what have you. Archaeologists use it to recreate things they find, and video game programmers use it, artists use it to make masks, all kinds of things. So there's a lot of applications to the technology. Some of the drawbacks: high resolution scans mean large files, which means you're going to have a larger computer hard drive. Usually post-processing is required for the lower end scanners. If you want to, these things can run up to like 100 grand, 200 grand, so they can get very pricey. Another thing is that it requires high-end technology like RAM. Now you need high RAM because RAM basically limits the number of points that you can create when you're creating your surfaces. So if you're dealing with a sophisticated component, your computer could crash because you just don't have enough RAM. Another thing is processor speed. The faster your processor speed, the faster you're going to be able to generate surfaces, the faster you're going to be able to render these images and just basically do the whole process. It's going to definitely make a difference if you're in industry.